Hey everyone, so today we're going to go over proving a function is even or odd algebraically, but I'll show you what it looks like on the graph pretty much. So let's look at our typical parent function y equals x squared. Our basic function is directly cut in half by the y-axis, so this is typically known as an even function. Even functions are symmetric across the y-axis, so any function with this type of property is considered even. Now if we look at y equals x cubed, it doesn't have symmetry across the y-axis, but there is symmetry across through the origin. Like if you were to flip it and rotate it, kind of flip it and reflect it. Yeah, you get this part of the function lying directly on top of this part of the function. So odd functions are symmetric through the origin. Now, how can we show that algebraically? So if you want to prove that a function is even, you want to show that f of x, or the original function, is equal to the function when you substitute negative x, alright, specifically negative x. And why is it negative x? Well, because it's flipping across the y-axis, so instead of having positive x values, it's going to be negative x values. So let's see how that looks like. So you would say, okay, f of negative x instead will be, and since you're substituting negative x, you're replacing any part of the function that has an x value with negative x. And you need to make sure you put parentheses. So instead of x squared, it's negative x squared plus 4. Alright, so what's negative x times negative x? That's positive x. So it ends up being x squared plus 4. And you see that you end up having the exact same function as the first one, which is a good thing. So this ends up being an even function. Okay, let's check it out on this one, a little bit more complicated looking. So you're going to take g of x and substitute negative x into it. You get negative x to the 6 plus 4 times negative x squared plus 2. Any time you raise a negative variable or number to an even exponent, it's going to be positive regardless. So this does end up being x to the 6 plus 4x squared plus 2, which is the exact same formula as the original function. So yeah, this is still even. So to sum that up, as long as you can prove that the original is equal to the function when negative x is substituted into it, that's an even function. And of course, if you were to plug it into the calculator, that's another way of determining whether it's even or not. But if you're studying for the regions, they do want you to show it algebraically. But for personal sake, you can graph it and say, okay, what does it look like? Oh, this looks like an even function, so I should be able to prove that this is even, somehow, some way. Alright, so let's go to odd functions. So to prove a function is odd, we need to show that when we substitute negative x into the function, it's equal to multiplying the entire function by negative 1. So let's split that into two. So this first one is going to be h of negative x. So just substituting negative x into the function. So what do we get? We get h of negative x equals negative x cubed minus 2 times negative x. Okay, well, when you are raising a negative value or variable to an odd exponent, it's going to stay negative or stay the same sign. So this remains negative x cubed, and this becomes positive 2x because a negative times negative is a positive. Alright, so this is what h of negative x looks like. So let's see what we get when we multiply this function entirely by negative 1. So bring that over here. What is negative h of x? So we're going to do negative or negative 1 times the entire expression cubed minus 2x. We're going to distribute, so boom, boom, negative x cubed plus 2x. And hey, we get the same thing, right? Alright, so this means that it's odd. The function is odd. Okay, so keep in mind, even functions only require one step where you're just substituting once, but odd functions require 2 steps. Okay, you need to see if the substitution works. You need to see if the substitution works with just multiplying it by a negative 1. All right, last one. What does a function look like when it's neither even nor odd? Well, we just call those functions neither. So let's see. Let's test to see if it's even. So even, we show that the original is equal to the substitution. So f of negative x equals negative x squared minus 3 times negative x plus 4. Well, this is definitely going to stay the same, so it's x squared, but this is definitely going to change, so it's plus 3x plus 4. So this is no longer the same, so it's definitely not even. So not even. Alright, let's see if it's odd. To prove that it's odd, we take that substitution, and we'd see if it's equal to multiplying the entire expression by negative 1. So negative f of x is going to look like negative 1 times x squared minus 3x plus 4. And I could already see a problem because that 4 is definitely going to change signs. So negative x squared, this is also different too, plus 3x minus 4. So you see, these two are supposed to be equal if they're supposed to be an odd function, but they don't match up. Right? The only thing that's the same is that middle term. The end signs are different. So this is not odd either. So then what would you say? You would say f of x is neither even nor odd. And that's it. So if you have any questions or comments, leave them in the comment section below. Like and subscribe, and I'll make more videos for you guys later. Bye.